My name is Greg George, and we're going to walk through reverse engineering this turbo impeller that was captured with a GOM scanner. I will just kind of outline the steps as I go along, and we'll go through it. All right, so the first thing is we'll do an auto segment. I'm going to set it for around 20. Let's see where we're at there. And I'm just checking the size, so it looks like this is about 300,000 triangles. And sometimes what I'll do here is I will zoom in. I will choose a nice set of blades that I'm going to use. And while I'm still in regions, I might merge those together just to make it easier to do my fitting of my CAD surface later. So that one's already kind of there. This one's pretty good. And on this one, just make sure it doesn't wrap around the end. And then, yeah, we'll go ahead and merge that and that together. And I mean, I could do that notch, but it's really not a big deal. All right. So the first step is we're going to model the center revolution. And before I do that, I'm going to go ahead and create a center vector. I select both planes before I click on vector. If I do that, it will automatically decide that because I have two intersecting planes, that is the construction method that I want to use. So once I have that, I'm going to right click and go to mesh sketch. And then I'm going to use rotational method. When you do a rotational method, you can click on the vector that we just created and then a plane that you want to use. And then what I'm going to do is I'm going to adjust my silhouette range to let's do like 40. So if I adjust it to 40, you'll see that it does 40 degrees and it's going to flatten all that back to the plane here. And I could go all the way around, but with this type of data, it's nice and clean. I can see it's pretty accurate. So what I'm going to concentrate on doing is modeling just this center piece, not the blades. So ignore this outer shape here. So I'll come in, and there's a lot of different methods for quickly sketching things out. And one of them is using rectangles to your advantage to where you can automatically draw horizontal and vertical lines quickly that are already trimmed to each other and already have horizontal and vertical constraints on them. So I like to do that where I'll just draw out a rectangle and then delete the other two ends. And then, oops, I don't want to delete both of the ends. I only want to delete one of them. Then I can draw this portion here. And I usually try to rough stuff in like this. So I'll just draw a horizontal line and then snap it down there. And then up here, it's hard to tell what's going on, but if you turn on the scan and then turn off regions, you can see that there's kind of like a straight line, straight line, straight line there. So that's what I'm going to make it. So I'll just go ahead and click. And I'll just create some geometry and then I'll move it into place. Sometimes I like to do it this way. And in this, we'll get that into position. And then sometimes it helps to kind of have there. The scan data, you can turn it on and off and kind of position it from there. So I'll do a corner trim, the second option there. Now, you could do a variety of ways. I could fit a curve here or draw multiple curves. What I think it is, because I've done this before, is a constant radius. So what I'm going to go ahead and do is just trim these two as a corner trim and then do a fillet. And you see it went past over here. So what I can do is trim this stuff together. If I use the extend, I could say extend out there, then come over and do a corner trim from this to that, and then go ahead and delete this guy because of where that ended up was up there in space. And then this all looks pretty good over here, and I should have kept that vertical too, by the way. So I'll just make that, when I drew that initial rectangle, I should have kept the vertical, and I could have dragged it over here to do that. So corner trim there. So you see, this is what my goal is, to create that inner revolve profile. And you can use right click menu there to exit out of the commands and exit out of the sketch as well. Now it's time to do a revolve. There are two different kinds of revolves in here: a revolve solid and revolve surface. We're going to do a revolve solid in this instance. I point that out because later on we're going to do some revolve surfaces. So you see that it disappeared when I hit OK. That's because the solids are hidden. So there you go. So the next step is we chose what blades we wanted to use, what sections, by rotating around, and I don't even remember which one. It's not a big deal. I could just select new ones, but this one right here. So for today's, there's a bunch of different ways of extracting these, but for today's presentation, we're going to do mesh fit. It's a nice basic way to get started here. And I'm going to go ahead and do it based on 25 and 25 nodes. Oops. So what we're telling it is this surface patch that it's going to fit over that reference, the scan. That surface patch is going to have a grid of 25 by 25, the resolution of that surface patch. If I hit next, it'll give me a preview. And it's a little bit wrinkly there, so let's just take a look at it here and see what we end up with. It's a little more wrinkly than I wanted, but you're not stuck with it. You can come in here and adjust the settings, so I can apply a little more smooth, and I can even lower this down resolution wise. I could say 20 by 20. And see, now if it's still an issue, it could be because that region is kind of wrapping around the edge. But for what we're doing today, that's fine. Like if I was going to do this as a project, yes, I would make sure that I get a little bit better fit than I got right now. And speaking of that, we'll go ahead and fit the other side, the outer side. And you see that is wrapping around the edge. So what I'll do is I'll come over to regions. I'll use this line. And I'm going to insert a region. And it's going to kind of trim off the edge there to make sure that I'm not wrapping that surface around the edge when I don't want it to. And we'll come back over to mesh fit again and select the side. And I'll just bump it one notch for smoothing because we did before. So there, I fit both sides of my wheel. So we did the first two steps. Revolve the inner piece, fit the two pieces here. The next one is we are going to do a revolve surface that accounts for this shape on the outside. So in order to do that, I have my other sketches. You see where I created that sketch before? Right here. I will come in and create another mesh sketch, revolution method. The center axis is that one that we created before, right here. Base plane is that same one right here. And then, I'll just go ahead and use that same 40 degrees. And we're going to draw this. So again, you know, there's some tricks to this where if you want to do it this way, you can. And I kind of like roughing things in with lines. So you'll see I'll best fit a line here. And then I'll do all my corner trims. Actually, before I do that, I need to move this into position. So I'll do a corner trim there, corner trim here, corner trim there. And then let's check where that constant radius fillet ends up. Yep, that works for me. And I make sure that I extend this past the inside because I'm going to use this as a surface trim later on. You'll see what I mean. And when I do my revolve, make sure I revolve it as a surface. Now, because of the way I'm going to be trimming stuff together, I don't want my revolve surface to go all the way around because it makes the trimming more difficult in the software. So if I go to both directions and then I drag these arrows backwards, so I'll go ahead and type in 10. There we go. So now you can kind of see, I'll drag it there and there. And it can help to turn on your surfaces to see where they're at. So make sure this goes all the way through. Hit OK. So I want to make sure that intersects all the way through these two surfaces. Now, one trick that I like to use, you could do another revolve sketch where you just draw a profile that's inside of this material here. Or you can come over and do a surface offset for this internal piece here too. That's another way of doing it. So what I mean here is, again, if I go back into Mesh Sketch, rotational method, this is the first way that I said. And 40 again. And if my sketch ever flips the direction, I just feel more comfortable this way, I can do that. So if I just draw like that, draw these, move those into position, make sure it's inside of the material, and then we'll do a giant fillet here. There we go. And the reason why I use this method instead of the offset method is because sometimes when I use the offset method, the surface trim struggles when it's 360. So remember when I said don't go all the way around here, 180, and I'll just do like 10. Is just there's something about when I go all the way around, the trimming is inconsistent. So I find it better to just go ahead and make another sketch with an internal shape. So what we have here is the inner and outer sides of the blade, an inside and an outside. And as long as all of these pieces intersect each other 100% and form a solid, you can come over to the menu, Insert, Surface, Solidify. And you can select these 4 sides. That's essentially what this is. 4 different sides to a solid. And I missed that one. So as soon as I hit OK, you'll see it disappears because my solids are hidden. There is my blade. And again, I have a little bit of chatter there because of the fit. But I'm going to go ahead and do a full face fillet on this anyway. Yes, I would fix this if it was a project. But full face fillet, you can select the 3 surfaces and it will do a constant radius between all those. Alright, so there's one blade. And now if I turn this on, you'll see that we have 2, 3, 4, 5, 6, right? So I'll just pattern body. Rotation axis can be that same one. Type in 6. And then equal spacing 360. Cancel that out. Grab it again. Grab my center of rotation again. There we go. All right, now for the other side. All I really need to do, modeling wise, is fit these two sides as a mesh fit again. Everything else is ready to go. So if I go to mesh sketch, I will leave that same setting, hit OK. Mesh sketch again. OK. Now, remember the inner and the outer. When I created the solid out of all that solidify, it made all those surfaces go away. All the construction entities disappeared. Now, in order to get those back, what I can do is I can roll back in time in the history tree to before. Did it just roll back? Let's undo. I'm going to not suppress, roll back. I think that's what I accidentally hit, suppress. And what I'm going to do is the inner and the outer, the ones that I want to reuse, I'm going to come over. This is a confusing situation here. But if I ever want to copy and paste a surface and just reuse it, the best way to do it is, in my opinion, use the transform body. So I'm going to grab these two surfaces, hit duplicate, and don't move it. So it essentially made a duplicate of the outer and the inner because I want to do another retrim solidify. So if I roll all the way to the end again, I have those surfaces. So now I can take, let's just turn off my other solids right now. The revolve and actually just everything, all of them. One problem I have here is this one is a little bit different, right? Because the top surface here is different from the top there. So one thing that we did before on this type of model is I went ahead for the small one. Let me just double check and make sure I got the right one. This one right here. I came in and I just made a region and I did a surface trim on it. So if I select that, I come over to regions and I hit insert. I'm just creating a region right along that edge. Now if I come over to wizard surface primitive and I say plane, I'm going to extend that like 400%. Oh, so it's telling me it doesn't want to fit because it's labeled as a cylinder, so I'm just going to get out of that. Click on that region, come over to properties, and change this to a plane. And now when I go back in here, surface primitive, plane, 400%, next, creates it for me. There. So I have all these surfaces. Now the same process that I went through before. These guys. I'm going to go to insert, surface, solidify. Grab all of those, hit OK. Turn on all my solids, turn my mesh off, and there you go. Now it didn't like that top surface trim, so what I'm going to do, I'm going to take that surface plane out of it, out of the solidify. I'll just clear it out and I'll do everything but that one because it will trim it together without it. Now, instead of doing it all together, I'll just come back and do a cut with surface. keep this body. Now there's a whole host of different ways of doing this. I'm just trying to do it in a very basic way to teach the baseline concept. And then from there, there's other methods that dive deeper into best practices. Also, there's different types of impellers, right? So I would take slightly different approaches depending on the geometry that's available. Now, I go ahead and pattern this circular pattern. This body, this axis, still 6 instances. Be careful of your selection. See, I accidentally selected the wrong. So that body, click on rotation axis, that axis. Okay. And then you can go ahead and merge everything together. So grab all the solid bodies and merge. Then if you want to do things like fillet, so you can, I didn't mean to grab that, sorry. If I go ahead and create a fillet all the way around each one of these, so you can go ahead and add these. Let me just calculate from mesh and then type it in as 1. So you could come back and add your fillets and so on and so forth. But that is a baseline process of how to reverse engineer an impeller inside of Geomagic Design X.